everyone, in this video let's discuss about the D flip-flop. You can call D flip-flop as data or delay flip-flop. Data or delay flip-flop. So we also know that in all types of flip-flop we will be having one input as common input, that is clock. So clock will be acting as a common input in all the types of flip-flop, whether it may be D flip-flop, toggle flip-flop, JK flip-flop, SR flip-flop. In all types of flip-flop, clock is the one common input. Now let's write the block diagram of D flip-flop, circuit diagram, truth table, characteristic table and excitation table. So if you write in this order itself, it will be much easier because one step is dependent from the previous step, like that. Now let's write the D flip-flop block diagram. So in block diagram what we will be doing? We will be just representing what are the inputs and what are the outputs. So if you see, D is the one input in D flip-flop, that is data or delay, and another one common input is clock. I will represent clock using CLK. And in all types of flip-flop, we will be having only two outputs. One will be Q and another one will be Q bar. You can use any variable, A bar, B bar, like that also. So what is the main funda means? One output must be complement of another. If one output is 0, another output must be 1. If one output is 1, another output must be 0, like that. Same output is not allowed in flip-flop, only the complementary outputs are allowed. Now let's write the circuit diagram. So to write the circuit diagram of the flip-flop, you can use NAND gates or NOR gates. So let's use NAND gate here. So first let's represent the latch. Later let's represent the flip-flop. So we will write the latch. We will be using two NAND gates. One will be output Q and another one will be output Q bar. That is complementary outputs. And output of one will act as input to another. Output of another will act as input to another. Like this. Now, if you see here, we just draw the latches. We want to construct the flip-flop. So I will be adding another two NAND gates in front of them. So now we constructed the flip-flop. So first let's give the input, that is D. D is the common input for both of them, and clock is also the common input. Clock value will always be equal to 1. That is, it will be in the on state in every condition. So what we will be doing is, we will be adding NOT gate here. That is, complementary inputs will be given to both these NAND gates. If one is given as the input from D, using this NOT gate, this NAND gate will be getting 0 as the input. If you give 0, using the NOT gate, this NAND gate will be getting 1 as the input. Like that, complementary inputs will be given to the both NAND gates in the flip-flop. Now, let's write the truth table. If you see, clock and D are my inputs, but clock value will be always equal to 1 and it will be in the on state in every condition. So I will just take D as my input and my output will be present state output, that is Qn plus 1. Qn plus 1 represent present state output. Now, since I am having only one input, what will be the combination? Combination will be 0 and 1. When D value is equal to 0, that is, when there is no input given using the data or delay, no output will be given, that is 0. When D value will be equal to 1, when the input is given, you will be getting the output. So you will be writing 1. 0 is equal to 0, 1 is equal to 1. Simple. Now let's write the characteristic table. In characteristic table, what happens means, this data and the previous state output will be used as the inputs. Data D or delay D and the previous state output Qn. Qn represent previous state output. So D and Qn will be used as the inputs and output will be same, that is Qn plus 1, present state output. Since I am having two inputs, possible combinations are 0 0, 0 1, 1 0 and 1 1. So I said that when D value is equal to 0, that is no input is given, since The input is only dependent on D, as clock value will always be equal to 1. When D value is 0, no input is given. So you just write 0 directly. When D value is equal to 1, the output will be coming. So just write 1, 1, 0, 0, 1, 1, like that. Now let's write the excitation table. In this excitation table, what happens means, this previous state output and present state output both will be in the input side. That is Qn, and Qn plus 1 will be acting as the inputs and D will be my output. Previous state output and present state output will be using as the inputs and D will act as the output. Since I am having two inputs, my possible combinations are 0, 0, 0, 1, 1, 0 and 1, 1. Now 0, 0, Qn is equal to 0, Qn plus 1 is equal to 0. What is the value of D? D value is 0. When Qn value is 0 and Qn plus 1 value is 1, what is the D value? It is 1. When Qn value is 1 and Qn plus 1 value is 0, what is the D value? It is 0. When both Qn and Qn plus 1 value is equal to 1, D value is 1. So this completes all the 5 steps in the delay or data flip-flop. So hope you understood the concept of how to write the characteristic table, excitation table, circuit diagram of the delay or data flip-flop. If you have any doubt regarding this topic, please do comment below. I will clarify it. And the playlist link of flip-flop is given in description. You can access it. If you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.